Hello and welcome to yet another video of Cornerstones of Math. Today we are going to evaluate these two partial sums given that n is an arbitrary natural number. The first one is the summation of k times k factorial, and the second one is the summation of k squared plus 1 times k factorial. So the first one, and actually let's solve this with two methods. In the first method, we attempt to manipulate this general term k times k factorial before we do anything about the summation. There's nothing much we can do with k times k factorial, but we can use the fact that k plus 1 times k factorial is equal to k plus 1 factorial. Therefore, in k times k factorial, we write this k as k plus 1 minus 1. So we have first k plus 1 times k factorial, then minus k factorial. And this part right here is k plus 1 factorial. So we have k plus 1 factorial minus k factorial. Therefore, the given summation can be written as sigma k plus 1 factorial minus k factorial. So it is 2 factorial minus 1 factorial plus 3 factorial minus 2 factorial plus 4 factorial minus 3 factorial and so on, up to n plus 1 factorial minus n factorial. So we have plus 2 factorial minus 2 factorial, plus 3 factorial minus 3 factorial, and 4 factorial gets cancelled as well, and in the end n factorial gets cancelled. So we are only left with n plus 1 factorial minus 1 factorial, so 1. The second method is good old bashing for the first few n's and guess the general expression method. So let us try n equals 1, 2, 3 and so on and see what we get. And here are the first few results. When n equals 1, we obtain 1. When n equals 2, we obtain 5. When n equals 3, we obtain 23. When n equals 4, we obtain 119. And when n equals 5, we obtain 719. Now, if you are familiar with the values of factorials, you can easily notice that this is equal to 2 factorial minus 1, and 5 is equal to 3 factorial minus 1, and 23 is equal to 4 factorial minus 1, 119 is equal to 5 factorial minus 1, and 719 is equal to 6 factorial minus 1. Therefore, it is reasonable to guess that the partial sum for general n must give n plus 1 factorial minus 1 for all natural numbers n. Let's prove this with mathematical induction. First, when n equals 1, then from here we have 1 plus 1 factorial, which is 1. And from here we have 1 plus 1 factorial minus 1, which is also 1. So our guess is true when n equals 1. Now assume that for some natural number k, 1 times 1 factorial plus 2 times 2 factorial plus 3 times 3 factorial plus so on, plus k times k factorial is equal to k plus 1 factorial minus 1. Then we add k plus 1 times k plus 1 factorial on both sides. Then we have this plus k plus 1 times k plus 1 factorial is equal to, first this, k plus 1 factorial minus 1, plus this, so k plus 1 times k plus 1 factorial. Here we write k plus 1 factorial at the front. Then from here we have 1, and from here we have k plus 1. Then we have this, so minus 1. Therefore, we have k plus 2 times k plus 1 factorial minus 1. And notice that this part is equal to k plus 2 factorial. So we have k plus 2 factorial minus 1. So the statement is also true when n equals k plus 1. And this concludes our induction proof. Therefore, for all natural numbers n, this summation is equal to n plus 1 factorial minus 1. And now the second one. Just like the previous one, let us examine this general term k squared plus 1 times k factorial and see if we can manipulate this into something else. Notice that this k squared plus 1 can be written as k plus 1 squared minus 2k. So we obtain k plus 1 squared times k factorial minus 2k times k factorial. And here, this k plus 1 squared times k factorial is equal to k plus 1 times k plus 1 factorial, right? So we have this minus twice the k times k factorial. Therefore, we can write our summation as, first, the summation of this. So the summation of k plus 1 times k plus 1 factorial. Then the summation of this. So minus 2 times the summation of k times k factorial. And for each term, we can use the result of problem A. Especially for the first summation, the expression is simpler if we let k plus 1 as j. Then we have the summation of j times j factorial, where j is from 2 to n plus 1, minus 2 times the summation, where k is from 1 to n, of k times k factorial. So as for this part, we can write first the summation where j goes from 1 to n plus 1, and then we subtract the term where j equals 1, which is 1 times 1 factorial. So we have this, and applying this, so first from here, we get n plus 2 factorial minus 1, and then minus 1, and from here, we have minus 2 times n plus 1 factorial minus 1. This simplifies to n plus 2 factorial minus 2 times n plus 1 factorial, which is equal to n plus 1 factorial times n plus 2 minus 2. So we have n times n plus 1 factorial. And that's all for today's video. Thank you for watching. Please don't forget to hit the like and subscribe buttons if you enjoyed this video, and I will see you in another video.